those one first. I'll bring them here. That's better. Ja, det är klart.
Okej, han pratar efter mig så jag ska be honom att komma hit så att han får sin så ska jag be den tredje att komma hit.
Basically this.
Exactly. Could you please give it to Mark? To Mark or to yeah, give it to Mark.
Or we're just going to do a hand roll.
No, you're gonna get one because we only have
Okay.
four. So
Should I sit on that side over there?
when you go on stage. Okay, I need somebody to help me organize the mic thing. You have the agenda, so when the you are after the once Mark is
Yeah,
finished.
yeah. Will he
or
have
or
it? Will he have it
Hans,
like that?
They're gonna have it, but right now it's me. It's one more. Joris.
Okay, okay.
Joris is gonna give it to Mark.
And where are they all sitting? Here?
Joris is over there. Johan can give it to you. So I'll ask Johan to give it to you.
Okay.
No, that's not true. Johan needs to give it to Hans. Joris needs to give it to Mary. So, yeah. Well, after the finalist speech, you should take it. So just go there and we'll make sure that you have the mic.
Hello. There you go. To me. Say hello to me.
Okay, we're gonna get going. Thank you all for coming. My name is Carina Varket. I'm a researcher at Stockholm Environment Institute, and I'm also the project coordinator for the Bonus Return project. So what I'm going to do is I'm going to keep my words very, very short, because today is about our finalists, less so about us in the project. So Bonus Return is a three-year project financed by Bonus. It started 2017 and it's going to be running until 2020. Forgot this. So I'm not going to give you the whole story of the very boring description of work and the 25 deliverables and tasks and deadlines. What I'm going to tell you, it's my attempt of an elevator pitch. And this is a real challenge as a researcher, because our pitches are about 2-day conferences. So now I'm going to give you my pitch in 2 sentences. What is bonus return doing? In contrast to traditional research that very often explores a question for the sake of research, because you're interested or curious about research, our research departs from a demand or a needs-based approach, where several years of previous research and previous projects, pro bonus and non-bonus, have led to how we formulated our questions and to understand what we think should be done at this point. So our approach is demand-based, and our aim is to produce evidence that identifies policy enablers or policy barriers. Our aim is also to bring together stakeholders to together produce whatever is going to be produced in the project, and to find sustainable, acceptable, and feasible solutions, but also explore the technical and the financial means of implementation. So our project goes the whole sort of way from research to policy recommendations to we will attempt to implement or bring things as close to implementation as possible, but also explore what's not really traditionally within the research boundaries, which is financial issues, policy issues. So we're getting outside of our comfort zone, and for this we need to work together with very many stakeholders that we usually don't work together with. So part of this part of the project that we will be talking about today is addressing specifically that. How can we do this? How can we work together to get some action going? We've got lots of research. We know what the problem is. We actually also know some solutions. But why is it happening at so slow pace? Why we see some improvement, but we're way, way beyond what needs to be done. And despite our very apocalyptic name of return, we are aware we're not going to save the Baltic Sea with a 3-year project, but we would like to contribute as much and beyond traditional research does. So this part of the project has called for innovations, to engage with the private sector, to apply for a research, to be part of our research and come up with fresh new ideas that might be very good, but somehow are not being financed and somehow they are not being implemented. So this is the pitch that we used in our innovation competition. Do you have an innovation with the potential to reuse nutrients and carbon in the Baltic Sea? Are you eager to improve your innovation, adapt it to local markets in the Baltic Sea, and meet with potential investors and clients? We got very, very interesting applications. Today we're going to present the 4 finalists from this innovation competition. These innovations fulfill the criteria that we outline in the competition. They address the issue of nutrient and or carbon reuse. So we are looking into recycling, not just capturing. It can be applied in the Baltic Sea. There are interventions, either chemical, physical, or biological interventions that are designed to minimize harm and to provide services of value to society. And they are also a prototype on the technology readiness level scale 5 or higher. What we're going to do with these fantastic innovations is they're going to walk with us throughout the rest of the project. They're going to be tested in our 3 test sites in Poland, in Sweden, and in Finland. And our fantastic partners in the consortium that you find on the left side from the Baltic Sea region will provide their different areas of expertise to bring these innovations as close to pre-commercialization as possible. We have the 4 finalists today: Carbonext from Sweden, Rabita from Finland, Terranova from Germany, and Aquacare from the Netherlands, that will be introduced in a little while. But before that, I would actually like to give the word to somebody who's meant a lot for Stockholm Environment Institute, as some of you might know, Johan Kuylenstierna. Before he leaves us, I really had to grab him to give us some of the last words of wisdom on how we can do this. How can we save the Baltic Sea, Johan?
Thank you. I will give you the answer. Thank you very much, Carina. Give her an applaud, first of all. It's really great to be here, and as Carina is saying, I'm stepping down after 6 years as the executive director at SEI, and you have some of the favorite projects. I shouldn't say that normally, but I should still mention that bonus return is probably one of my favorites because it is really at the center of combining innovation, science, technology with policy. It's just what SEI is all about, and also for many of the partners we have there. So it's really interesting for us, I think, to follow this program moving forward. We know that there are a lot of challenges in the Baltic Sea region. We have spent tremendous resources trying to address these challenges over the last decades. We have been successful in many places, but as we can hear on this conference and many other conferences, it's just not enough. And we could also hear from this morning, the urge or the need for combining different competences, getting different actors together, talking to each other, and working much more closely together. And this is what Baltic Return is very much about. And what I really like is also the mindset that you have in Baltic Return. The fact that you are looking at challenges, but you try to turn them into opportunities. How can we actually move forward by focusing on the opportunities? I think this links very well to the shift we have also at the global level. My argument is that this is exactly what happened between the Copenhagen climate negotiations and the Paris negotiations. The fact that we managed to shift from in Copenhagen talking about the burden sharing of the transition, because this was really in the focus in Copenhagen. And you don't engage people if you talk about burden sharing. Hey guys, let's come together and talk about how we should share the burdens. Instead, what happened in Paris is that we talked about how do we reap the benefits of the transition? How does it generate new businesses? How does it generate development in many different ways? That is what happened, I think, at the global level, why we managed to get the Paris Agreement, with a push also from communities, from local municipalities, from the business sector. It's not just about governments. And this is, again, a very good example of how bonus return is thinking. And this region is extraordinary. It's a very innovative region. Carina gave me some information before here, pointing out, for instance, that the Bloomberg Innovation Index, 4 out of the 10 top countries are actually from this region. Sweden, Finland, Denmark, and Germany. There is an explosion of environmental technologies. It's so much more, and there is a strong research base. There is so much more now about getting these together. The problem with the science, with the markets, with the innovation to solve the challenges that we see in the Baltic Sea. And there are many barriers, as you say, Carina. There are financial, legal, but also behavioral barriers, mindset barriers. We have conflicting policies within countries, between countries in the region. There are sector boundaries to overcome when you look at innovations. Energy should be combined with agriculture, with water, with whatever. I mean, there are so many different sector boundaries to also deal with. So the bonus return, what I really like is the fact that it is about bridging sustainability challenges, the sort of system challenges, and innovation and entrepreneurship, and build this on the science that we have. So the science is really a facilitator for this process, which I think is in itself a very interesting role for science in a broader sense. And we can see this more and more, science as a facilitator in pushing societal changes. And I think that what is also critical, and you helped me again there, Carina, you sent me some notes about the thinking you have, and I think that it's important to make a point from my perspective, why I also believe this is so interesting. And this is that you said it's about bringing together environmental goals. We have them, and we have set them, and innovation. This is what we talked about, innovation policies. But it's also about demonstrating that this can generate economic development and job creation. So that is actually really linking very well into the social dimensions of sustainability that we've had a tendency to underestimate when we are looking at transition. that is a much stronger driver to really get into those dimensions. And I think that many of the examples we have here and that we will discuss today and hear more about, they are at that interface between the different dimensions of sustainability. So bringing together researchers, innovators, decision-making, municipalities and businesses, it's clearly the way forward also when we address challenges in the Baltic Sea region. And as I said, I'm really pleased to see Bonus Return really now starting up this project. And I'm actually very optimistic about the future for the Baltic Sea region as well. So thank you very much for allowing me to be here.
Thank you, Johan. We do know that Johan is an optimist, so we hope you're right. That's right, there's no alternative. So now I would like to invite the finalists up here to the panel to join us here. So these are the 4 fantastic finalists from Germany, Netherlands, Finland, and Sweden. And again, I'm not going to take time with introductions. I think the best introduction is the one that you yourselves will do. So I would like to invite you, Joris Salden. I was about to say Saldén, but you are Dutch.
I'm Dutch,
so
yes, you're right.
Please come over here and tell us about Aquacare.
I will. Thank you, Carina, for inviting me here on stage. See, it's already ready. So and thank you all for giving me the opportunity to share with you what Aquacare can do to end eutrophication. And I will show you what our system is like and how we do that. So my name is Joris Salde. I'm Joris Salde and I'm responsible for a company called Aquacare based in the Netherlands. Originally, and still doing, is a water treatment company for already 30 years. With main business or operations in the Netherlands, Belgium, and the United Arab Emirates. So we have a team of 26 very hardworking people. Oh, that's wrong. And within that team, we are currently, since 3 years, really investing in research, especially in phosphorus removal and recovery. So our journey on this innovation began approximately 3 years ago with searching for materials that are able to absorb phosphorus from water streams. And we did, since then, a lot of lab testing and ways to find out how we can get the phosphorus out of water and then again recover the adsorbent. Last year, we were awarded by a foundation called the George Barley Foundation with the first prize and the prize is for the best idea to bring eutrophication to an end in a very big lake in Florida, which is called Lake Okeechobee. And also at this moment we are rewarded by 2 Dutch water boards with letter of intents to start pilot testing to make an end to eutrophication by absorbing phosphorus and then recover the phosphorus again from water as a fertilizer. And as I'm speaking now, we are testing a pilot in Ontario, cold water conditions, just like, let's say, it also can be here in Stockholm or Scandinavia, where we are challenged to bring our system to life and to clean up water totally from phosphorus and to make a fertilizer from the recovered phosphorus. So, what's our system like? Imagine a river and a lake here in the front. We put a small building there, and I gave you an insight of an installation we already built with an absorption installation that is regenerable, and the regeneration fluid can be recovered. So in a scheme, it looks like this, very simple. We have, in fact, 3 main processes. First process, the big one, is to absorb phosphorus in water. That's not so special. but then the adsorbent gets completely full, and we are able to regenerate that adsorbent easily. And then you have a fluid, a regeneration fluid, that contains phosphorus, which could be waste, and that's not the idea. And we separate then the phosphorus from the regeneration fluid. And that's what really is the main part. So you get a liquid containing phosphorus, and you get an effluent stream with phosphorus less than 3 ppb. And if that's not enough, of too low, you can always mix it up a little bit, so you have still some life in water. The nice thing is that it's very easy to scale up. You only need to add more large influent adsorbent facilities. And I got here a picture of quite a similar installation that exists in the Netherlands, and it's treating approximately 3,500 to 600 cubic meters per hour. Takes out a different kind of nutrient, but it is possible. And if we do it well, then we clean up rivers and lakes, and you get some great sea life again. So far, we've proven that the technology works, and we can get as low as less than 3 ppb in water. We have a patent pending on separating phosphorus from the regeneration liquid. And we are currently at the technical readiness level 7, which means that we are already working in a real market situation, small scale. And we are able to successfully reuse the regeneration fluid that regenerates the adsorbent. So the great advantage of this system is in fact 3 things. One is it is very simple. So 3 main processes. It's scalable from very small to very large and easy to design. Second thing, that is eco-friendly. It consumes very low energy. It has a very small footprint, and it is environmental friendly. So besides the concentrated phosphorus, there's no chemical leakage to the environment or other waste streams. And when possible, we have a recovered product of phosphorus that may be a good fertilizer in the future. We don't know yet. So what are the opportunities? The challenges for us is that we are trying to enter a new market. So I'm looking forward for people or businesses or companies who wants to put a real-life pilot test, small scale, where you have a need. And we are trying to commercially find out if it's commercially feasible to recover phosphorus. As you know, you see here that phosphorus ore costs only $1 a kilo, and as a product recovered, it costs around 64, we calculated, so that's quite a lot. But what we have now is eutrophication problem, and what you all want is to end that, and I'm sure that we can bridge that and fill the gap with our system. So for the future, please get to me in contact if you want to try a pilot system in Scandinavia, in Sweden, or Letland and Estland. And we will happy to discuss how we can do that. What we still need to do is prove the benefits of the concentrated phosphorus liquid, so how it can be used. And what we don't know, or maybe a good side effect, is that it can also take micropollutants out of the water, but we don't know yet because we don't know what's in it, but it absorbs everything. So that's what I want to share with you. And yeah, this is what AquaCare can do. So make an end to eutrophication by taking out phosphorus from large water streams. That's my story. Thank you.
Thank you. Stay here for 2 minutes. In case there's any questions from the audience, we have a few minutes over there. Let me get to you the...
For? Good question. No, not that we know. Not that we know of. No, no. That's. Well, I explained already. So adsorbing phosphorus has not been done on this scale yet. There are many materials that have the characteristics to be able to do that. But then, the separation at the end of the regeneration fluid, there is the trick, and that's a breakthrough. You're right. The profit, good question. So there is, let's say, we cannot calculate the profitability of making an end to eutrophication. I yesterday saw in a presentation that it costs here around the Baltic Sea 2 billion a year economically. So somewhere, let's say, the cost of this must come out of the cost of that economic problems for eutrophication. And about the reuse of the liquid phosphorus, that's only an extra, but it's not currently not feasible from an economical perspective.
Wait. I think they do need the mic. Halvram.
Thanks. I just have a question. Can you only work on water streams, or can you work on lakes? Do you need to work on the rivers with your technology?
The challenge we are running now in US, so the goal is to treat the river that ends in the lake, and that it will clean up Lake Okeechobee in years. But of course, you can try to minimize or to absorb the phosphorus from the lake itself. You can do that. Yeah.
My question was similar, actually. It looks like you're addressing point source phosphorus emissions rather than diffuse source phosphorus, which is probably the diffuse sources are also a sort of a leading reason for eutrophication.
I did not understand.
The diffuse sources of from agriculture, for example, where it's very difficult to sort of...
True.
Have you thought about using the technology or ways of using the technology within the diffuse context?
We are thinking about that one, but currently it's very, let's say, we also need to focus on something. Let's say, so for the Netherlands, where we have feet on the ground, is at wastewater treatment plant for a community. And we just we are trying to polish the effluent. So that is quite a good way to treat it. But for lakes currently, so where all streams come, water streams flow into the lake, that would be more difficult. That's true. Yeah.
We have one more question over here.
Is it only dissolved phosphorus in the water?
Soluble.
Dissolved.
Yeah.
You can't catch the organic bound phosphorus.
Well, I talked about this morning with rice. So the particulate phosphorus, you need to filter that out. But that is more a process that is quite known, not that very difficult, I think, to take out particulate phosphorus.
But how do you catch the dissolved phosphorus if you're not filtering the water?
We are filtering, but I could show you some extra pictures of filters, but that would not impress you. So you're right. First, take out the particle, and then the dissolved one.
Thank you for your questions.
The installation in Canada has first filtration, and then absorption.
Juries will be available, like the rest of the finalists, at the end of the session for a quick mingling, so that you can just go around and ask more questions. They can explain a little bit more in detail how things work. Thank you. Thank you so much.
Good luck.
Our next finalist is Mark Böttman from Terra Nova in Germany. Thank you, Mark.
Karina, thank you, Karina. Would you change? Yeah, thank you very much, Karina, for the introduction, and I'm glad to be here to present our technology. I would like to talk about two exciting products. One product is coal, but this is not just a regular coal, it is a climate-friendly coal, because the coal is made from renewable biomass. So it contributes to the storage of renewable energy, which is an increasing importantly topic in the renewable energy sector. The second product I would like to talk about is phosphorus. We heard phosphorus around 2 days now. Phosphorus is a scarce resource and it's vital to humankind. And it will run out in about 100 years. And the special thing about that phosphorus here is that it is recycled phosphorus. So by recycling phosphorus, we save the natural resources. The common thing about both of these products is that we use one and the same waste input to produce it. And the waste input is sewage sludge. So what is sewage sludge? Sewage sludge is a side product from wastewater treatment. And it bears basically three big problems. The first problem is that it is polluted. It is polluted with contaminants from the wastewater stream. And this is basically heavy metals, organic pollutants like pharmaceutical residues, but also bacteria and so on. The second problem with sewage sludge is that it contains around 80% of water, which means there is a big mass that has to be disposed, and incinerating sewage sludge as a disposal path requires a lot of energy. And the third, probably most important problem right now is that it is expensive to dispose. In Germany alone, Germany spends around 4 billion Swedish crowns every year for the disposal of sewage sludge. But we offer a solution to that. We use that sewage sludge to produce these two products here. So we take the sewage sludge, we run it through our system, which we call Terranova Ultra, and we gain two products. The renewable coal to protect the climate change, to generate renewable energy, and phosphorus. Now, this is not just an academic idea. We already have a first reference project in Asia. And the next movie shows you some impression about that installation. The installation is on a wastewater treatment plant in the city called Jining, which is 600 kilometers south of Beijing. This shows just the silo, the sludge silo, where we get the input sewage sludge to treat. We take the sewage sludge and push it into our system, which is at elevated temperatures of around 180 degrees and 25 bars of pressure. So we completely break out the sewage sludge into its components. We follow now the way of the sludge into the so-called carbonization reactor. This is where the conversion from the sewage sludge into the coal takes place. We have implemented a quite sophisticated heat recovery system to reach very low specific energy consumption. The system, of course, is fully automated. It is remote control, so it doesn't even need supervision. What you will see now is how we extract the water from the sewage sludge. As I said, 80% of sewage sludge is water, and this is where we take it out. After the process, we can easily take out the excess water from the sewage sludge. And the final product is the coal, the climate-friendly coal. which falls out of that filter press. That coal is now used in a power plant in Jining to generate electricity and heat for district heating. So the overall advantages here is, first of all, that we reduce the amount of sewage sludge by 70%, 75%. We recover the energy from the sewage sludge that is embedded in the biomass. We can recover the phosphorus, and we save cost for a wastewater treatment plant. So our technology was awarded with several quite renowned innovation awards. One of them in 2015, we were awarded Innovation of the Year of the German economy, which is the first innovation award worldwide. So what we would like to do now with the help of you is to implement a next reference project in Northern Europe. After China, we would like to have a reference here in Europe. So what we would like to have is find municipalities that are interested in solving their disposal problem. And I think the nice thing about it is that this is even profitable because the municipality will save disposal costs in the future and by that contribute to a large extent to an economically friendly solution. So that's the end of my presentation. Here are my contacts, and I'm happy to have a discussion later on. Thank you very much for your attendance.
Thank you, Mark. Before you go, I already see hands. Okay. So you're first, Johan, and I'll go after Johan with the rest.
Thanks, really interesting. Can I ask you a quick question? You said you were looking now for a project in Northern Europe. You want to test it here. You have tested it in China. Can you say a few words? Why did that happen? I mean, it's a German innovation. It's tested in China. Is it because we are locked into all technologies in Europe and it's difficult to shift? Is that the main problem?
Because no, I think China, let's say, especially in Germany, German municipalities are quite reluctant applying new technologies. Yeah? And that's totally the opposite in Asia. Specifically in China, they always want to have the newest technology available. And of course, in China, there are lots of investments being done right now into solving the sludge disposal problem. Whereas in Germany, or let's say in Central Europe, all municipalities have somehow their specific solution to get rid of the sewage sludge. It might not be very energy sufficient, it might not be resource orientated, but they have a solution somehow. So that makes it difficult really to develop projects in Europe, or more difficult than in Asia. So that would be the answer. Of course, we have a pilot plant in Germany where we developed the technology. We are now building a pilot plant for the phosphorus recovery as well. And in the future, we hopefully, with the help of the bonus return project, we would also like to introduce recovery of nitrogen, which also is easily to implement based on our technology.
Question about the residual heavy metals. So where are they, and what stream, and what do you do with them?
Thank you very much for that question, because it's extremely important. As I said, there are heavy metals in the sewage sludge. We cannot fade them away. Yeah? So they will remain in the coal, and this is where they have to be, because that coal goes into cement kilns or large power plants, which have the technology to absorb the heavy metals and to collect them. Which means the phosphorus product that we recover is free of heavy metals.
Yeah, I just have a question about what you called climate-friendly coal.
Excuse me, about?
A question about the climate-friendly coal. I was
Yes.
just wondering if it goes into power plants, then does it emit carbon emissions, or
Sure.
is it different to other
No,
coal?
no. I mean, it's similar like wood. If you burn wood, of course, burning wood causes CO2 emissions, but this is the same amount as it extracted from the CO2 cycle a couple of years ago, and that's exactly here the same thing. It is a renewable biomass that we use. Sewage sludge is a renewable source, so the overall net effect is zero.
Okay, so other questions, please. Same as with the rest of the participants, I would invite you to go around at the end of the presentations and ask further questions. Our next participant is not coming so far away from here. Sweden, CarbonX, Hans Kjellberg.
Yes,
Welcome.
clicker. There we go. There we go. Hi, my name is Hans Kjellberg. I'm a professor of business administration at the Stockholm School of Economics, where I study market development and change. But that's not why I'm here. I'm here as a partner of CarbonX, which is a startup which is based in Uppsala that is developing a negative emission technology for producing carbon and hydrogen. Of course, my knowledge about market creation and market dynamics also comes in handy here, because our innovation will require us to reshape some of the existing markets around biogas. So what's our innovation then? Essentially, it's to harvest carbon that is currently in atmospheric circulation and use that to restore the terrestrial carbon cycle. Our starting point is biogas. The production of biogas currently is geared towards either combined heat and power plants or is being upgraded and used to fuel vehicles. What we're doing is trying to develop an alternative route for biogas, which, it can help improve soil quality, it can reduce emissions from agriculture, forestry, wastewater treatment, and in doing so, it will also simultaneously reduce the CO2 that is currently in atmospheric circulation. The net technology as such is, we call it CarbonX PACE. It's a scalable technique for extracting nanocarbon structures out of upgraded biogas. And in extracting that carbon, we also get hydrogen as a side product. So let's see, I should click. There we go. So specifically, we're focusing now on developing carbon structures that can be used to improve agricultural soils or be used as filter materials in wastewater treatment. And these nanocarbon structures even show potential to accelerate the digestion of solid waste in wastewater plants, thus leading to increased biogas production in those plants. You may have heard of biochar, which is typically produced from wood using pyrolysis. You can think about our carbons as customized biochars that have been harvested from biogas. So PACE is short for plasma-assisted carbon extraction. And it's a reactor technology that is currently in use for other purposes, but our route of using it for soil improvement is new. We've recently conducted a series of initial lab tests with a French research partner that shows that we can extract or harvest solid carbon structures from biomethane or upgraded biogas, but we've yet to verify the exact characteristics and performance of those structures. A major drawback of ordinary biochar, which is used to treat soils, is that the quality of the biochar is dependent on the raw materials you use to produce it. Well, the advantage of PACE is that we can tailor the recipe for a specific carbon, and then we can produce large batches of that, exactly that carbon quality or carbon structure. So we can develop particular signatures that can be used for specific purposes. In the slide, you can also see some key figures about the production process. So, under optimal conditions, processing a ton of biomethane or upgraded biogas will produce 750 kilos of carbon, 250 kilos of hydrogen, and at the same time reduce the CO2 in circulation by 2.8 tons. So this means that a modern medium-sized biogas plant like Jordberga in Skåne would produce 7,000 tons of carbon and 2,300 tons of hydrogen each year, and at the same time reduce CO2 in circulation by 26,000 tons. So, how could Carbon Next be of use in the Baltic context? Well, first of all, our technology will be able to harvest substantial amounts of carbon from circulation. Moreover, since this is a net technology that draws on the stock of carbon in circulation, we will produce or continue to reduce the level of CO2 even if we were to reach a zero emission scenario. The ability to control what carbon structures we produce also allows us to tailor them to specific purposes. So in the context of the Baltic, which is the area of expertise of one of my partners in the company, we believe that our carbon structures can produce the following ecosystem services. They can help lock nutrients and improve water retention in treated soils. They can absorb pesticide residues, heavy metals, by being applied to either in the landscape or at point sources. They can increase microbial life and carbon sequestration in the treated soils. And they can increase water buffering capacity in wetlands, so to reduce nutrient emission during intense precipitation episodes. And finally, I think this is important, our innovation will contribute to increased climate positive energy security for the Baltic region by developing new areas or new uses, new applications for biogas, increasing its versatility. And with our technology, biogas producers can choose to produce climate neutral biogas under periods of high energy demand, and then switch to climate positive carbon and hydrogen when energy demand is lower. So where do we go from here? Well, we see both opportunities and the need for cooperation with other actors in order to take our innovation further. So first of all, this should be of interest to biogas producers, municipal or privately owned. We know from our analysis of the German biogas sector that they are, of course, struggling now with finding new business opportunities in the face of radically decreasing subsidies. We also know that other biogas producers in the Baltic region find their competitive situation problematic due to differences between national subsidy schemes. And then if we look at the farmer side, where we intend to apply our carbon structures, let me put it this way. There's a lot of business opportunity here. Just a moderate 10% reduction in fertilizer costs for a crop farmer would translate into a 100% increased profitability. So the potential of applying these carbon structures into the soil are really, really good. Finally, let me see so I don't miss anything. What we're doing right now, we just received a grant from Energimyndigheten in Sweden to do a technical pre-study for a pilot plant. And we're of course looking for a partner to engage in that project with us. So over the course of the next year or so, we will be looking into the technical specification of a first plant using this technology and would be very interested in finding a partner for that. Thank you very much, and I'm happy to take some questions.
Thank you so much, Hans. Are there any questions for Hans before moving on to the final presentation? You can always approach him after this round of presentations. Yeah. Thank you so much. And there you are. Mari Heinonen from Ravita.
Clicker.
Let me fix your presentation.
see you all here, and I'm proud to present our Ravita innovation. I'm Mari Heinonen from Helsinki Region Environmental Services, and actually I'm working as a director of wastewater treatment plants in Helsinki metropolitan area. So I have a total different background, and I'm not presenting this as a company, I'm presenting this innovation as a municipal utility. So I have a bit different focus on this innovation and business models for the future. The fact is that the present technologies which are available for nutrient recovery and especially for phosphorus recovery, they are not available for everybody. They are not available, for example, in that sense what we are thinking as a large wastewater treatment plants in Nordic countries. We cannot do phosphorus recovery because we are not doing for biological phosphorus removal in the Nordic countries. And on the other hand, we are not burning the sludge, which is the other path for phosphorus recovery from the ashes. And then, of course, one issue what we already discussed in a previous presentation is the price. At the moment, recovered phosphorus price is extremely high, and you cannot really compete in an open market with a virgin type of fertilizers with a recovered one. And we started to think that we should somehow shake this idea where the phosphorus is going to the sludge, and then we have a mixture of organic materials and heavy metals and phosphorus. We should do something else and think out of the box. And we had this Ravita innovation. It's actually a spin-off from our phosphorus removal project. And it's the idea where we recover phosphorus directly from the wastewater. And here you can see the idea of, idea of Ravita is to recover phosphorus after the normal wastewater treatment plant. And normally we are doing a lot of things inside of the wastewater treatment plant and try to put everything to the sludge. But now in this innovation, we let phosphorus go through the treatment plant. And it's in the very end, when the water is already clean, there is no organic material, we are doing phosphorus precipitation. And we are creating chemical sludge, which is very rich of phosphorus and very low amount of, for example, heavy metals, practically none, or organic compounds. And then after that, start to process that chemical sludge, and we will end up to phosphoric acid. And that's the key issue. We want to create a product which has a wide market potential, not only fertilizer industry, but other industries also. For example, pulp and paper industry, even food industry. In your Coca-Cola, you drink actually phosphoric acid on it. And then other thing, we want to have this internal circle for precipitation chemical. We do not want to use virgin materials anymore in the future. So this is one of the innovation inside of the project. Of course, we are producing still biosludge, but there is a minimum amount of phosphorus on it. You can do biochar or something else. It's much more, you can think more freely when you are not having the phosphorus inside of this, let's say, traditional stream. And this can be also combined with nitrogen removal and recovery. Recovery of nitrogen is mainly based on stripping, and this phosphoric acid can be used as a washing chemical in a stripping process, and in that case, we are producing ammonium phosphate, which is a fertilizer ready for the market. And why I'm here? I'm here because in the future, we have to, of course, work still on this demo plant. The TR level of our innovation is at the moment between 5 and 6, so we have to continue. And I would like to, of course, discuss with other municipalities, other colleagues, is there something we should fix and rethink, or is there some limitations which we cannot see, or Then, on the other hand, with other business, let's say units, for example, I have a good experience about the ecosystem thinking in Finland. We have, for example, cooperation with pulp and paper industry, UPM, battery, recycled battery technologies which are using phosphoric acid. So I want to think also out of the box in that scale. So not only fertilizers, which is of course important part of the phosphoric acid end users, but also other technologies, other businesses. So these are the things I'm interested in to meet here. And Ravita is also part of the government key projects in Finland, so there are 3 technologies nominated as a key projects based on our Ministry of Environment, and Ravita is one of those. So it's also followed by ministerial level. Thank you.
Thank you so much, Mari. Are there any questions for Mari? Yes.
You said that this was a kind of this project was generated from the wastewater sector. Actually, what about Ravita as a company? Is it?
No, it's owned by our wastewater treatment plant.
Okay, so there's no specific organization around Ravita. Okay.
At the moment, no.
I have a similar question as before to our colleague from Germany. This technology and this process that you describe, is it easy to apply to existing systems, or does it require a lot of separate investments? And
what you need, if you do not have a polishing system already, that's possible that you already have it, and actually you are already producing this sludge. You need this POX, which means precipitation unit, and also the separation where you take out this chemical sludge. You can easily use this based on the need. If you do not need to do that good quality of the effluent water, you take what you need, and this means that you can use this process also as a harvesting unit, which can be, if you think globally, the problem of phosphoric lack in the future, we have to think harvesting, not something side stream, So this gives a possibility also for harvesting. So you can adjust it, but it needs investment if you do not have a polishing system.
Thank you, Mari. So our next speaker is Mark Klaus from Race for the Baltic. Mark is going to talk about his accelerator program, and this is a concrete way for you to potentially engage in the Baltic Sea region, but beyond the bonus return projects. So, Mark, please come up here.
Thank you.
Thank you.
Just quickly. Then if we go view full. Does it have to be moved into?
Technical help. This is a collaborative project.
It looks great here, but no one else can see it. See if this will move it. Since I know we're on a very tight time schedule, I'll try and get started just by, first of all, congratulating the finalists. I think it's quite unique to have this question brought up, a competition around this, and then to see the geographical spread. It was a Northern European competition that went out, and then to see that RISE and SEI and the other partners in this project actually were able to attract both the interest from so many and then make selections that represent also such a spread in terms of where the finalists have come from. So there will be, I think, a prize after this as well, but you and the others that have participated in this competition, we're very interested at Race for the Baltic, which is the organization I represent here today, feel that these kind of platforms, these kind of competitions, raising awareness about the possibilities to address the issues of the Baltic Sea in an innovative way like this is very exciting. And I think collaborating with Bonus Return on this is a benefit for us, and I'd like to at some point maybe see a few slides to help illustrate or talk about this with you. Apologies for that. Maybe just as a start, there's no, I wonder if I can see it here, but if it goes over to the other screen for some reason. Let me see if, do we have internet connectivity? Or you know what, can we try and connect my computer? I just know the timing is.
Sure, I'm not sure how that works. But should we go to the next presentation before? So we get some time to fix your presentation.
Sure, let's do that, that's okay.
So Måns, I'm gonna put you on the spot. He's a really funny guy, so he'll do good.
No pressure. Thank you. I'm not going to be funny here. This is serious business. So my name is Måns Lund. I work for RISE. And here in the Bonus Return project, I work specifically with tests and the test bed and such. So I'm supposed to present what you will win. So what you will win is that we will help you and perform tests, tailor-made, and tests can be in test beds, external, internal, where we might find them suitable. And try to match the product to the local needs. That's the Baltic region. So, together with you, of course, and obtain tailor-made procurement and business plans and sustainability plans. So it ticks the boxes of a good sustainable practice. Then it's, of course, a lot of networking, and there's links with the private sector and investors, because you want to reach out to those who potentially will buy your stuff. And then, and in that introduce the product to the potential markets. So that's basically what you'll get, and I hope I'm sure we'll have a good cooperation in doing that. And I'm finished. Thank you.
Does anybody have any questions about the prize? Any performance? Any songs you want to sing? So now we got it going.
There we go. Alrighty. The Baltic Sea City Accelerator, the Baltic Sea Accelerator, is an initiative of Race for the Baltic. We've been collaborating with Bonus Return on this project. As you can see here, one of our aims is to connect innovators with municipalities and investors. I understand some of the projects were maybe not just for the municipality side, but in the projects we've been working, we've had a effort to bring the cities and the municipalities together with the investment community, but also with innovators and solution providers such as yourselves. The next one there. As a foundation, we're focusing on a number of programs to restore the health of the Baltic Sea. What we do is we convene key players from a range of sectors and catalyze and support initiatives, collaborate across the entire Baltic Sea region. We're transboundary in our approach. Key to our vision is to change and frame the challenges of the Baltic Sea as an opportunity for a clean environment and a more prosperous region for all. And by this, we look at cities, businesses, investors, government investors, and citizens. Partially, this comes, of course, from one of our main backers and initiative and founders of the organization, Niklas Sennström, who's an experienced entrepreneur, and encourages us, and also is the way we encourage others, is to see these challenges as an opportunity, to look for solutions to them, to act as agents, if you will, to bring and pool the proper resources and knowledge together to support the development of ideas and innovations around these key challenges and issues. And to connect the region and accelerate the solutions. As I mentioned to begin with, our flagship program that we ran until the end of June 2017, over 18 months, was with 12 cities around the Baltic Sea who worked together, worked with us, worked with investors, worked with solution providers to look at the challenges they have, in this case specifically with eutrophication, and look at ways to approach these, but with an investment lens, to see what are the socioeconomic benefits of addressing these questions so that it's not an environmental cost to clean up, but it's also an investment business case that they could develop around these. We work to accelerate the commitment of the leadership, which is key, but also to work with them on the local level to see if there were other initiatives that already were taking place that they could work with together to develop a Baltic Sea action plan on the local level, drawing on what the plan is that HELCOM has set forth as well, but to bring that to a local level to reduce the nutrient flows and create this business strategic approach, getting a little bit to Johan's point too. How can we see the opportunities here? How can we change the framework for approaching these issues? And then, of course, accelerating solutions to address them. We have in this program a Baltic Sea Solutions Accelerator, which matches cities with solution providers and brings in together with partners from both science, which of course is very important in addressing environmental challenges, bringing the science community in as well with the investors and the solution providers to look at what are the challenges the cities are facing, to look for innovative ways and methods to address this. And I'll get back to some of the hurdles that we had in the program, but it also becomes a way for us forward to look at how we can more accelerate solutions that are coming out, particularly in this case for eutrophication. So in the process, there's a matching process as well. It's also collectively, collaboratively identifying the problems and the solutions together, looking for ways to develop very firm and simple next steps that can be taken. Oftentimes, the challenge being rather complex and large leads to the issues maybe being over ambitious, and you have to take it step by step, create the small wins that then can also attract the next stage of confidence for funding going forward as well. A piece that we feel is not that is rather important is not just involving the private sector in it, but to do these projects with an eye towards, can we scale? Can we share and learn from other projects that have been done before? We know there are a lot of very interesting projects that have been achieved, but they're oftentimes very isolated, maybe done in a more of a research environment as opposed to an investor or business perspective. We heard some of that on the stage before as well in the large room. There are programs, projects out there, but are they being done on a level that could be scaled, or are they being done with a business perspective in mind? Timing-wise, I'm going to just pop through a couple of those slides there and give some of the observations we had in the City Accelerator program when working with solution providers, the cities, and also the investment community. And I think this is the part here which there are no easy solutions to. But I think if we're aware of where the barriers lie or where the hurdles still are, we can work together collaboratively to iron them out. What we heard and what we saw from some of the solution providers in the Accelerator program was that they come in with innovation, entrepreneurial drive, interest in making a change, looking at possibility to create new profitable ways of dealing with environmental challenges, but they meet a slow-moving market, at least in the Baltic Sea region. And it could be because you have legacy systems that you've already invested in that you're still trying to optimize, well, not optimize, but get the last of the life cycle out of, or there's no real need or pressure to change or bring in some of these more efficient technologies. So there's sometimes that frustration, and it's key to these kind of platforms is to find those municipalities that are ready to move, both because they want to make a difference or to adopt new technologies, but also because they have to. And part of the work we've been doing is to give them these tools to see that there can be benefits in moving a little faster in this direction. It's also hard, we've seen, for solution providers to, once you get to a certain technical readiness level to approach the market for a pilot, to find that match, to find a potential customer who's willing to take that step together in the first hand. And then the presentations, fantastic today. Nowhere, however, did I see what it would cost to do one of these. And I know we're at that stage where perhaps those weren't included in the presentations for other reasons, but those are the questions you're going to find, and it's that commercializing the innovation and how to bring it in and finding the business models that are going to work in a public-private situation that is key. And it's identifying those and figuring those out at the stage when you don't have all the variables for your Excel sheet that is a challenge, and that's why you need these pilot projects very early on. From the cities and municipalities, and I'm happy to see some of them here today as well, the economic cost of environmental cleanup is still seen as a cost. And so programs that can show and point to the other benefits that can be achieved through addressing these issues are key. We worked with cities on that as well, and then when you get those trade-offs in place, you of course see the opportunity to make investments or take these stages in a completely different light. At the same time, we have to recognize when you're dealing with these issues and elected officials is there's a tendency, and it's kind of somewhat of a paradox, to want to play it safe. You want to be seen as an innovative community, you want to be a leader, but you can't have a headline the next day or come election time that shows that that investment wasn't a safe one. Whether it's in IT systems or environmental systems or new technologies, there is a safe tendency to want to play it safe. And I think that to find ways to allow innovation to come into municipal procurement, whether it's through green or innovation or other pieces, is key. And that requires also that the municipalities are willing to work on that, but also sometimes on a national level to encourage and stimulate that. They're getting the ideas of circular economy. We're seeing it, it's there, but of course there's still some hesitancy to step too fast. And then the piece that Alexander was bringing into the picture as well is, the money is there, and I think everyone would say, well, it's very hard to get at sometimes. The application processes can be challenging for municipalities that either don't have the resources or the experience with it. And the projects that the investors are trying to get and involved in or invest in might not have that investor readiness or that perspective that they're used to doing. So there's a new language that's being formed here between, let's say, the environmental or the innovators and the investors for that's needed. And to bridge that is dialogue that takes time. And I think platforms or projects such as Bonus Return, if you bring in the idea of these are business opportunities that we want to see scale, and you understand that even at the very small level, you're doing that with an eye towards scale, and the fact that this is a situation that isn't just the municipality where I'm now working or the farmer I'm now working with, but more, then you're going to have an opportunity to, I think, attract different investment levels. And also from the investment side, they're looking at ways to package their financing structures in a way that makes it easier for smaller projects to come in as well. We invite them, and we invite you as well to participate in programs such as ours, where we bring the investors, the projects, the municipalities, if you will, as potential customers, but also, and I think this is mentioned as well here as well, these are new technologies that sometimes will come in on the backs of other technologies. And so it's working together with a wastewater treatment plant that's already established or a biogas reactor that's already in place, and then finding those ways to make their model more efficient and make the work for the municipality also better. We see this as a sea of opportunity. We welcome all that are interested to join us as we work with cities and solutions on accelerating them. This came up also yesterday with reference to the HELCOM meeting in Brussels. There are benefits to be had. You can see it from a negative side. There are losses by what we're doing, but of course there are huge economic benefits as well. And we welcome the finalists to join us as we proceed with our next round of the Accelerator program. We will continue to work with platforms and projects such as Bonus Return, where we can see possibilities to bring together the multi-sectoral approach that's required from this. And congratulations again on being finalists in this program, and thank you again for a chance to work with you at Bonus Return.
Thank you so much, Mark. So we've come to the end of the presentations, and now it's time for you to stay and drink coffee. We brought the coffee here, so you can't leave the room. We hope you can go around and ask questions to the participants or to us, to the project. You have suggestions, ideas, you're very welcome to share them with us. I'm just wondering, how many of you have the money in the pockets? Because we went to a session where they said they had lots of it, and that they were just ready to invest, and I was thinking, that's great, they're going to come to my session. But I think for us, at the other end of the line, research and municipalities, we hear this, but we don't see them. And so do you have any ideas on how to get them to come to this session, or what format they want? Do you see it a champagne glass, or is it a coffee style, or is it a lunch? Please come to me and tell me your secret, how to attract that money that is so broadly available. And I close my presentation because I want to leave you our contact details before we leave. And I want also to ask Johan to come and help me out. The technology, that's not the one. Technology is not working with us today. Hopefully this technology is. So you can get my card, and hopefully you don't lose it afterwards, as I do. But I would like to call each one of you to come up here. Joris Salden from Aquacare, thank you so much for participating. Just look over there. I got other instructions. Okay, thank you. Thank you so much. Mark Buttman from Terra Nova in Germany. Sorry, I moved. Hans Kjellberg from Carbon Next in Uppsala. Ann-Marie Heinonen från Ravita in Finland. Great, thank you so much. This was very excruciating with the pictures. I'm very happy to be relieved from the stage. Please approach our finalists. They all have a table in each corner of the room. Just attack them, please. Thank you so much for being here.
Det här har de haft problem med här. Vi har ju haft världsveckan här. Det här är inte ovanligt. Jag fattar inte heller.